Hi guys! In this video, I'm going to show you how to calculate the work that it takes to pump the water out of a tank. So let's take a look at this problem. An aquarium 2 meters long, 1 meter wide, and 1 meter deep is full of water. Find the work needed to pump half the water out of the aquarium. The first step is to draw our aquarium. So as you can see, I've drawn our tank. It is 2 meters long and 1 meter wide. The second step is to place the X and Y axis like this. So you gotta place the X axis at the top of the box and have a Y axis pointing down here. The Y direction is positive in this case. And at this point, it is 0, and this point is 1, because here the problem says that the tank is 1 meter deep. So from here to here is 0 to 1. The problem wants us to pump all the water from 0 to 1/2, because that's the same as pumping out half the water in the aquarium. So that means from 0 to 1/2. Now you can imagine that from 0 to 1/2, there are many layers of water, like this one that you can see here. I'm not going to draw all the layers of water, but you can imagine that there are many layers of water. And what we're going to do is we are going to pull up each layer of water. We're going to pull this layer of water to the top. Last but not least, the distance that we're pulling each layer of water can be called y. We are now ready to solve this problem. So what's the formula to calculate the amount of work to pump all the water out? Well, the work formula is going to be equal to W, which is work, is equal to the integral from top to the bottom. And I'm going to show you how to find these numbers later. And here we have density times the distance that we need to pull the layer of water to the top, and times the area. And this area is basically the area of the layer of water. And then we have dy. What is the top and what is the bottom? Well, remember, we're pulling all the layers of water from the top, which is 0, and the bottom is 1/2. And because of that, the bottom will be 1/2 right here. So this would be 1/2, and the top will simply be 0. Now, how about the density? Well, if the problem is in meters, if they give you the length in meters, then the work will be in joules, and the density will be 9,800. So the density in this case will be 9,800. If the problem gives you the length in feet, then the work will be feet-pounds, and the density will be a different number, so it will be 62.5. The distance is the distance that we need to pull each layer to the top. And as mentioned before, that distance is simply y. So the distance here will simply be y. And then how about the area? Well, what's the area of the layer of water? Well, you might learn before that the area of a rectangle, this is a rectangle, is equal to the base times the height. And we already know that the base is 2 meters. So the base is 2, the height is 1. So 2 times 1 gives you 2. So the area is simply 2 meters squared. I'm going to put in 2 for short. And let's get rid of this. Let's evaluate this integral. So 9,800 times 2 will give you 19,600. So W, or the work, is equal to the integral from 0 to 1/2 of 19,600 times y times dy. So since this is a constant, we can move it outside of the integral. So we get 19,600 times the integral from 1/2, and here is 0, y. This is the same as 19,600 times the antiderivative of y, which is just 1/2 times y to the power of 2. And we have 0 and 1/2 at the top. This is the same as 19,600 times 1 over 2 times 1 over 2 to the power of 2 minus 1 over 2 times 0 to the power of 2. Let's close that bracket. Now 1 over 2 to the power of 2 is 1 over 4. And 1 over 4 times 1 over 2 gives you 1 over 8. So this is equal to 19,600 times 1 over 8. And this will simply give you 0, so minus 0. And now 19,600 times 1 over 8 will give you 2,450. And that's it. That is the answer. And the unit will be joules. Remember, because the length they've given us is meters, so the answer will be 2,450 joules. So this right here is the answer to this question, and the amount of work that it takes to pump half the water out of the aquarium. We're going to be doing some more practice problems with calculating the amount of work to pump the water out of a tank. So this problem says a tank has the shape of an inverted circular cone with a height of 10 meters and a base radius of 4 meters. It is filled with water to a height of 8 meters, and we have to find the work required to empty the tank by pumping all of the water to the top of the tank. So the first thing we have to do is draw out our diagram. So here is our circular inverted cone. It has a height of 10 meters, and we also know that the base radius, or the radius from here to here, so that radius is the same as 4 meters. The second step is to place our x and y axis. So remember, you have to place the x-axis at the top of the shape, and you have the y-axis running down like this, where the y direction, the positive y direction, is pointing downwards. So this point will be considered 0, or the origin, and this point will be 10 because the height from here to here is 10 meters. So the point here, it will be 10. We know that the tank is filled with water to the height of 8 meters. And 8 meters, that would be from here to here, right? So this means that this point will be 2 because 2 to 10 is 8 meters. That's the difference between this distance. So that's why this point will be 2. The question asks us to empty the tank, which means that we're going to pull out all of the layers of water. So there are many layers of water between 2 and 10. And let's say this is just one layer of water. I'm not going to draw out all the layers of water, or else it's going to look very messy. But basically the idea is that for every single layer of water, like this one, we're going to pull it to the top of the tank, right? And we're going to do this for every single layer of water. And that's basically how we empty this tank. So the distance that we pull this layer of water to the top will be considered y. So the formula that you want to use is W, or the work, is equal to the integral from the top to the bottom of density times distance times area dy. So what's the top and what's the bottom? Well, the bottom is right here and the top is right here because we want to empty the tank from 2 to 10, right? So the bottom will be 10 and the top will be 2. How about the density? Well, if you look at this table, the problem has given us the length in meters, so the work will be in joules, and the density will be 9,800. The distance is y, as mentioned before. How about the area of the layer of water? So if you look here, this is a circle, right? Which means that the area of that layer of water is equal to pi times the radius to the power of 2. So this is pi times the radius to the power of 2. And the radius is from here to here. That's the radius. And the distance from here to here is x because it is horizontal. So instead of r, I'm going to write it as x. So this is equal to pi times x to the power of 2. Since the equation, or rather the formula, is dy, we have to change all of our variables into y. So let me show you how to do that. Now, if you look here, this is a line, right? That looks like a line. So you can use what you learned in high school to find the value of y instead of x. Now this point right here, this point will be 4, 0. Why is it 4, 0? Because the distance from here to here is 4, which means the distance from here to here is also 4. So this is 4, the height is 0. And how about this point right here? Well, that point is 0, 10. Because the x value is 0 at the origin, and the y value is 10. And notice that 10 is a positive number because we're saying that this direction is positive. You know, it's better to work with positive numbers than numbers that are below 0, right? Now, we can use these points to find the slope formula. And these 2 points are, let me write them out here, for 0 and 0, 10. So the slope m is equal to 10 minus 0 and 0 minus 4. 10 minus 0 is equal to 10. 0 minus 4 is negative 4. We can simplify this into negative 5 over 2. Now our equation will be y is equal to negative 5 over 2 times x plus b. And we're going to substitute this point, let's say this point right here, we're going to substitute this point into our equation. So we substitute y is equal to 10, and then x is 0. So 0 times 5 over 2 will be 0 itself, plus b. This means that b is equal to 10, right? Because this means that b is equal to 10. So we're going to delete the b and replace it with number 10. Let's solve for x. So I'm going to add to both sides. We get y plus 5 over 2x is equal to 10. We subtract both sides by y. We get 5. Oops, let me write a little bit below that. So 5 over 2x is equal to 10 minus y. And if we multiply both sides by the reciprocal, or 2 over 5, we get x is equal to 2 over 5 times 10 minus y. So that's how you find x. So we're ready to put it into our area equation. We're going to get pi times x, and x is equal to this, right? So we just put in 2 over 5 times 10 minus y. And now notice that here is x to the power of 2. So don't forget the power of 2 up here. Let's simplify this. So we get pi times 4 over 25 times 10 minus y to the power of 2. Let's evaluate this integral. So what is 9,800 times 4 over 25? I put into the calculator and it gives me 1,568. So this is equal to the integral from 2 to 10. This is 1,568, and don't forget the pi over here. So this is pi times y times 10 minus y to the power of 2 dy. And since this is just a constant, let's go ahead and move it outside of the integral. So we get 1,568 times pi times the integral from 2 to 10. And here we have y times 10 minus y to the power of 2 dy. Now, what is 10 minus y to the power of 2? Let's find out. So we have 10 minus y to the power of 2. This is the same as 100 minus 20y plus y to the power of 2. So let's go ahead and put this into our integral. And if you look here, we can also simplify this by multiplying this whole expression with y. So we're going to multiply each term with y. We're going to get 100 y minus 20 y to the power of 2 plus y to the power of 3. This is equal to 1568 times pi times the antiderivative of 100y. So the antiderivative of y, as we know, is 1 over 2 times y to the power of 2, right? So if we multiply this together, we are going to get 50y squared minus the antiderivative of 20y to the power of 2. Well, that's just going to give you 20 over 3 times y to the power of 3. And the antiderivative of this one is pretty easy. It is just 1 over 4 times y to the power of 4. And we have the limit. It goes from 2 to 10. And we can go ahead and close that bracket right there. So it is pretty simple from here, and all you need to do is substitute in these numbers for the upper bound and lower bound into the equation, and after you simplify it, you should get 1568 times pi times 2048 divided by 3. So that's what I have. After I put this into my calculator, I get 33628 to 7.797. And this is approximately 3.4 times 10 to the power of 6 joules, because remember the unit here is joules according to the table. And so this is the same answer as the textbook. So this number right here is the amount of work that it takes to empty this entire tank. So we're given a tank that is full of water, and the problem wants us to calculate the amount of work required to empty this tank. The first step is to put the x and y axis looking like this, where this direction is the positive direction for the y axis. So we know that our tank is 8 feet tall because the height is 8 feet. So that's why this point is 0 and this point will be positive 8. We also know that the radius of the top circle is 6 feet, so the distance from here to here is 6 feet, and the distance from here to here is 3 feet. To empty this tank, all we have to do is move every layer of water like this one. So there are many layers of water here. So we're going to move each layer of water to the top of the tank. And the distance from the origin to our layer of water is called y. To calculate the work, all you have to do is use this formula. W, or the work, is equal to the integral from the top to the bottom of density times distance times area. So what is the top and what's the bottom? Well, as mentioned before, we want to empty this tank from 0 to 8, right? So the bottom will be 8, and the top will be 0. How about the density? Well, according to this table, if the tank is measured in feet, in which case it does, then we need to use the density, which is 62.5, because the length is in feet. The density will be 62.5. The distance that we're pulling each layer of water is y, because we're pulling it to the top. So the distance will simply be y. Last but not least, we need to find the area. So this area is referring to our layer of water right here. So since our layer of water is a circle, the area of this layer of water is equal to pi times the radius to the power of 2. And the radius from here to here is x. So instead of writing r, I'm going to write it in terms of x. Since our formula is dy, we have to convert the x into the y. And let me show you how to do that. So if you look here, this is a line, right? So you can use the formula of a line to find y. We know that this point right here will be 6, 0. Because the distance from here to here is 6, right? And the height is 0, so therefore it will be Now, how about on this line? How about this point right here? Well, this point will be 3, 8. So this point will be 3, 8. And why is it 3, 8? Well, because the distance from here to here is 3, and the height is 8. Now notice that 8 is a positive number because we're saying that the positive y direction is right here. So let's write out our 2 points. We have 6, 0, and we also have 3, 8. The slope, m, will be the same as 8 minus 0 divided by 3 minus 6. This is the same as 8 divided by negative 3. So putting this into our point slope formula, we get y, which is the variable that we're looking for, is equal to negative 8 over 3 times x plus b. Now all we have to do is substitute in one of these 2 points. Let's put in this one. So y is equal to 0 and x is equal to 6. So this will be negative 8 over 3 times 6 plus b. And negative 8 over 3 times 6 is equal to negative 16. So therefore, b is equal to 16. And let's delete this b and write in 16. So here is our equation. Y is equal to negative 8 over 3 times x plus 16. Now let's solve for x. We subtract both sides by 16, so we get y minus 16 is equal to negative 8 over 3x. And then we multiply both sides by negative 3 over 8. So we get x is equal to negative 3 over 8 times y minus 16. So we finally found x, and we can substitute this right here into our x squared in order to find the area. So the area is equal to pi times x to the power of 2. And we know that x is equal to this expression right here, which is negative 3 over 8 times y minus 16, close the bracket, and to the power of 2. This is equal to pi times 9 over 64. So 9 over 64 times y minus 16 to the power of 2. And this is the same as 9 over 64 times pi times y minus 16 to the power of 2. Now that we found the area, let's go ahead and put it into our formula. We are almost done. The last step is to evaluate this integral. So this is equal to the integral from 0 to 8 times 62.5 times 9 over 64 pi times y minus 16 to the power of 2 dy. And since these numbers right here are constants, we can move it outside of the integral as well. So this is equal to 62.5 times 9 over 64 pi times the integral from 0 to 8 times y minus 16 to the power of 2 dy. Now, what is y minus 16 to the power of 2? It is the same as y squared minus 32y plus 256 dy. And now all we have to do is multiply each term with y, like this. We will get y to the power of 3 minus 32y to the power of 2 plus 256 times y dy. Now, after you find the antiderivative of this expression and then plug in the limit from 0 to 8, you will get the answer, which is 10,3672.5576. So that's what I get after evaluating this integral, and you can approximate this into 1.04 times 10 to the power of 5 feet-pound, because the unit here is feet-pound according to our table. And so this here is the answer and also the amount of work that it takes to empty this tank. In this video, I'm going to show you how to calculate the amount of work that it takes to empty a tank full of water. So we're given this tank. It is full of water, and they want us to calculate the amount of work required to pump all the water out of this tank. So first of all, we know that the length of this tank is 8 meters, and the height of this tank is 3 meters, and the width of this tank is also 3 meters. And then we have a spout like this. It's 2 meters, and we have to move all of the water and pump it outside of the spout. The first step is to place an X and Y axis with the Y axis pointing downwards this way. So this is the positive direction. The second step is to draw our layer of water. So this is one layer of water, and you can imagine that there are many layers of water from here to here, right? So in order to empty this tank, we need to move each layer of water like this one to the top and out of the spout. And so the distance from the origin right here, the origin of the axis to our layer of water, this distance can be considered as y. So the formula to calculate the amount of work to pump the water out of a tank is W is equal to the integral from the top to the bottom of density times distance times area. So first of all, what is the bottom and what's the top? Well, as mentioned before, we want to empty the tank from the top, which is here, to the bottom, which is here, right? So the top right here is the origin, which is 0. So this point is 0, the origin, and this point is 3. How about the density? Well, if we look at the table, we're given the length in meters, so the work will be in joules, and our density is 9,800. What about the distance? Well, the distance to pump it to the top is y, right? The distance we're pulling the layer of water to the top, right there, is y. But then we also have to pull it outside of the spout. We have to pull it outside of the spout as well. So the distance is just y plus 2. Last but not least, we need to find the area. So let me show you how to do that. Now the area of this layer of water, this is a rectangle. So the area is equal to the base times the height. Now the height of this rectangle is always 8 meters. Here it's 8 meters, as you can see. It is 8 meters, so therefore this right here will also be 8 meters. And how about the base? Well, the base is this distance, right? So first of all, from here to here, this distance is x, as explained before in my previous episodes. So this means that the base, the complete base, from here to here is 2 times x. And because of that, the area is equal to 16x. Since our formula is dy, we have to convert the x into the y. And let me show you how to do that. So if you look here, this point to this point, so this is a line, right? This right here is a line, and we know that this point is going to be 1.50. So that point right here is 1.50. And why is it 1.50? Well, because we know that the distance from here to here, this distance right here, is 3, right? So what is half of 3? Well, half of 3 is just 1.5, which means that this distance from here to here, that is 1.5, and because of that, this point is 1.50. Now, how about this point right here? Oh, that point would just be 0, 3, because it is located at the origin 0 and the height is positive 3. And notice that 3 is positive because we're saying that this direction is the positive y direction. And so let's write down our 2 points. We have 1.5, 0, and then we also have 0 and 3. This means that the slope m is equal to 3 minus 0 divided by 0 minus 1.5. This is the same as 3 over negative 1.5, which is equal to 3 divided by negative 3 over 2. And this is the same as 3 multiplied by negative 2 over 3, which is equal to negative 2. Right, so this right here is equal to negative 2. And let's go ahead and erase this right here. Our point slope formula will be y is equal to negative x, which is the slope that we found, plus b. And all we have to do is substitute one or these 2 points in here. And I'm going to substitute this point. So y is equal to 3 is equal to negative 2 times x, and x is 0, right? So this times 0, which just means that this right here is 0 plus b. So b is equal to 3. So let's delete the b and write number 3 right here. Our equation is y is equal to negative 2x plus 3. And we're going to solve for x so we can put it back into our area formula. So we get y plus 2x is equal to 3. Then 2x is equal to 3 minus y. So x is equal to 1 over 2 times 3 minus y. 16x is the same as 16 times x, which is 1 over 2 times 3 minus y, and we can close the bracket. 16 times 1 over 2 is the same as 8. Let's go ahead and put this into our area. The last step is to evaluate this integral. This is equal to the integral from 0 to 3, and then 9,800 times 8 will give you 78,400. And then times y plus 2 times 3 minus y, and don't forget the dy. Since 78,400 is a constant, we can move it outside of the integral. Now, what is y plus 2 times 3 minus y? Let's find out. We have y plus 2 times 3 minus y. Y times 3 gives us 3y minus y to the power of 2 plus 6 minus 2y. This is the same as negative y squared plus y plus 6. After I solved this integral, I got 1058400. So if you solve this, this is the number that you should also get. And the unit is going to be in joules. So this is going to be joules. And you can also approximate this into 1.06 times 10 to the power of 6 joules. So this right here is the answer, and also the amount of work that it takes to pump all of the layers of water out of the tank and also out of the spout. Hi everyone! In this video, I'm going to show you how to calculate the amount of work that it takes to pump all the water out of this three-dimensional sphere. So we're given a tank. This tank is full of water, and we have to find the amount of work to pump all of this water out of the spout. So the radius of this circle, or rather this three-dimensional sphere, is 3 meters. That's the radius. And we also know that the height of this spout is 1 meter. For a circle, what you want to do is put the x and y axis at the center. So this time, the origin is at the center, and the positive y direction is upwards. Okay, so don't forget that. To empty this tank, all we have to do is move every single layer of water from here to here, right? So this is just one layer of water, but you can imagine that there are many, many layers of water in here, just like this one. And we want to move it to the top. So we're going to move this to the top of the tank. Now, one thing to notice is that in our previous episodes, we have already established the fact that the distance from the origin to our layer of water is y. So what is this distance? Well, this distance will simply be 3 minus y. And that's because the radius is 3. The radius is 3, which means from here to here is 3. The radius is 3. And we know that this is y. So the blue distance right here, must be 3 minus y. So like I said, this distance will be 3 minus y, and our diagram is finished. We are prepared and ready to solve this problem. To calculate the work, we're going to use the formula that we have been using. But the only difference is that because the positive y direction is pointing upwards this time, the bottom will be down here and the top will be up here. Okay, so that's the only difference. So work will be equal to the integral from the bottom to the top of density times distance times area. So what is the top and what is the bottom? Well, as mentioned before, we want to empty the tank from here to here, right, in order to empty the whole thing. So the top will be 3 and the bottom will be minus 3. The density will be 9,800, right, according to our table, because the length given is in meters, and so our work will be in joules. As for the distance, we're moving each layer of water to the top, right? We're moving from here to here to the top, and the distance that we're moving to the top is 3 minus y. But don't forget, we're also moving it outside of the spout, so we have to move it out of the spout. And we know that the height of the spout is 1 meter, so we have to plus 1. And this is the same as 4 minus y. How about the area? Well, the area of our layer of water, so that area is equal to pi times the radius to the power of 2. And the radius is from here to here, and we can also call it x. So instead of writing r, I'm going to write it in terms of x. We get pi times x to the power of 2. Since our formula is dy, we have to convert the x into a y, and let me show you how to do that. We know that the equation of this entire circle, so the equation of that entire circle, is y to the power of 2 plus x to the power of 2 is equal to 3 to the power of 2, because the radius is 3 meters. This means that x squared is equal to 9 minus y to the power of 2. So we found x squared, right? This is x squared. This is also x squared. So let's go ahead and put it into our area. We get pi times 9 minus y to the power of 2. Now that we have the area, let's go ahead and put it back into our formula. The last step is to evaluate this integral. So since 9,800 and pi are both constants, we can move it outside of the integral. So the work is equal to 9,800 times pi times the integral from -3 to 3 of 4 minus y times 9 minus y to the power of 2. What is this going to be? Well, we have 4 minus y times 9 minus y to the power of 2. And this is equal to 36 minus 4y squared minus 9y plus y to the power of 3. We can also rewrite this as y to the power of 3 minus 4 times y to the power of 2 minus 9y plus 36. Let me save you the trouble of going through this integral. So after I went through this integral, I get 1411200 pi. This is the same as 4, 4, 3, 3, 4, 1, 5.553, which is approximately 4.43 times 10 to the power of 6 joules. So this right here is the amount of work that it takes to pump all of the water out of this tank.